Hey everyone, welcome back to the Physics 30 videos. In this video, we're looking at Unit 1 motion, and specifically here we're going to talk about acceleration due to gravity. So when we're working with acceleration due to gravity, we can use 4 of the 5 kinematic equations that we looked at in our last video. And here, if you guys notice, that the 4 kinematic equations that we're working with all have to do with acceleration. So the one that we're missing there is where we had that initial and final velocity, and we basically weren't working with acceleration at all. Because acceleration due to gravity, obviously we need to be working with an equation with acceleration here. And so one thing that would be important about these types of questions is that with acceleration due to gravity, that value, which we can use the letter G to represent it, or in these cases here, we use the letter A. But that value is 9.81 meters per second squared. So just a couple of notes here is that with this acceleration due to gravity, we typically keep it with meters per second squared. So any of our other values like displacement needs to be in meters, your time has to be in seconds. So we have to make sure we're working with the proper units, or we're not going to get proper conversions, meaning we're going to run into some problems. So, but this one here follows the same rules that we looked at in the last video, where when we have to figure out which equation we're going to use, we just write down our information and then figure out which equation we have enough information to work with. And also typically with these types of questions, they also give you next to no information about the situation itself, but so it's some stuff that we just have to know just based on experiences and just from our own, I guess, common sense, if you want to call it that. So we're actually going to look at example number 5 from your notes, and this is in the on your own section. So here a pebble falls from a ledge that is 20 meters high. So in part A of this question here, we're going to find the velocity with which it hits the ground. So one thing I need to make very clear, and this is one thing I've seen students consistently do, is that when something hits the ground, you don't assume that the final velocity is 0. Usually an object, when it's falling, it hits the ground with a certain speed, and maybe after it hits the ground, then after that it would have a velocity of 0. But not that moment of impact. So here we cannot assume that your final velocity is 0, and that is one thing that students consistently mix up in their examples and when they're doing their assignments. So here what we're going to do is we are going to write down our information. So here it just says that a pebble falls from a ledge. With this type of example here, we are going to assume that your initial velocity was 0. Just because it's falling off, we didn't push it down, we didn't throw it down. There's nothing else acting on it. It just fell down. So we can assume that that initial velocity there was 0 meters per second. And then here in the question, we are given that it falls from a ledge that is 20 meters high. So that's your change in your height or your change in displacement or that distance. So this one here is 20.0 meters. Then one other thing that we can say that we know for sure is your acceleration, which is that acceleration due to gravity. Here we're talking about vertical motion, and we're talking about a pebble that's falling. So here the acceleration acting on it is that gravity, which is the 9.81 meters per second squared, and the direction there is down. We are going to want a direction here because we are looking for velocity, which is a vector quantity, meaning we do need a direction. So then here we're going to find the velocity which it hits the ground. So here we're looking for our VF. So I'm going to leave that as my question mark. So now I've identified all the information that I know and then which variable I'm looking for. So I have my initial and final velocity, displacement, and acceleration. So I'm going to go look at my 4 kinematic equations and see which one I have enough information for. So in our first equation here we need to know our time, which in this case we don't. So we can already cancel out that equation there. In our second equation here, we have our displacement, which we have our initial, but we don't have time and we don't need to know it, so we don't need to know that one either. Looking at our third equation here, we have displacement, our final velocity, and once again, this one here has time, so I'm actually going to cross that one out. So that means that we only have this last equation here to work with. So here we have our final velocity, initial, acceleration, and displacement. So I'm just going to rewrite this out here. So we have our final velocity squared is equal to that initial velocity squared plus 2 times your acceleration times the change in displacement. So now that I've identified my equation based on the information that I have and what I'm looking for, now I can go ahead and plug in my information. So here I'm looking for VF, so I'm going to leave that as VF squared. So that's equal to your initial velocity, which was 0, plus 2 times acceleration due to gravity, which is 9.81. And here our displacement here was the 20.0 meters. So I'm just going to rewrite my VF squared. And so 0 squared is nothing. So it's 0, nothing. I don't have to put anything. So I'm really just going to go 2 times 9.81 times 20. So when you put that into your calculator, you should get 392.4. And then just to make sure I'm keeping track of sig figs along the way, I don't consider this 2. This is just a given value. 9.81 is a given value as well. So I'm only going to consider this displacement, which has 3 sig figs. So because here we were just multiplying, our answer here will use the multiplication rules. So we have 3 sig figs there. But we are not done yet, because if you guys notice here is that our VF value it's being squared. So to get rid of that square, we're going to square root each side. So VF, when you square root that 392.4, you guys should get 19.8 meters per second. And because this is a vector quantity, we need to make sure we have that direction, so it's down. When we square root, we're going to be following the same rules as multiplication division here, so this 3 sig figs here is good to go. And then this one here was, in a very short, small way, is technically a word problem. We're given a little situation about a pebble, so we do want to write a sentence for that one. So we could say the final velocity of the pebble is 19.8 meters per second down. So once again, just remember velocity is a vector quantity, so you need both a magnitude and a direction. And make sure you guys are keeping track of sig figs as you guys go throughout these problems. So now we're going to move on to part B. And so here what we're going to do is we're going to find the time it takes to hit the ground. And what I'd recommend with this one here is that we're going to use the same information that we're given in the question. I always try to avoid anything that we've calculated, because what happens if we made an error? So we're still going to be working with that same initial velocity, which was 0 meters per second, that same displacement, which was 20.0 meters, and that acceleration due to gravity, which was 9.81 meters per second squared down. This time here, though, we are looking for delta t. So now we're going to basically avoiding any equation that has that VF in it. So here we have our initial speed, initial velocity, our change in displacement and acceleration. We're looking for time. So going up to these 4 equations again. I know that because I'm not working with my final velocity, I can actually cross out my last one. We don't need that one anymore, so we need to make sure we're working with one that has time. Looking at our first equation here, this change in velocity is, we can rewrite this delta V as VF minus VI, meaning we're working with that final velocity, so we don't want to use this one. So then looking at our next equation here, we have delta D, VI, delta T, your acceleration, and that change in time again. So this one here has nothing to do with our final velocity, so this is the one that we're going to want to use. So it's going to start by writing out that equation. So it's going to start off with our change in displacement is equal to VI times the change in time plus 1/2 times the acceleration times that change in time squared. So now that I've identified my equation, I'm going to go ahead and put all my information into my equation. So my displacement here is 20.0 meters. Our initial velocity is 0 times that change in time, plus 1/2 times 9.81 times delta t squared. I'm just going to simplify everything before I start moving some stuff over. So 0 times delta t is just 0 because anything times 0 is just 0. So I can actually forget about this. So, but what I can work with though is this 1/2 times 9.81. I can simplify that to 4.905. And that's times your change in time squared. So then what I can do is I want to get this delta t squared by itself. So I'm actually going to divide by the number that's connected with that variable. Make sure what you do to one side, you have to do the other to keep that equation equal. So this cancels out on your left side, so you're left with just delta t squared. Sorry, that's on your right side, and on your left side, if you guys divide these two numbers, in your calculator should get 4.07747 followed by a bunch of numbers. And then I usually like to keep a couple into my calculator just until our final answer so we don't have any rounding errors. But anyway, so now what we need to do is we are going to square root the delta t squared to get rid of this exponent. And then what we do to one side, make sure you guys do to the other as well. So we square root this 4.07747. We should get a number like 2.0192, so on and so on. That's going to be equal to delta t. So in order to figure out how I'm going to be rounding, I can look at my significant digits. So I actually don't have to worry about this 1/2 times 9.81 because these one here were just values that were given. So I really only have to consider this 20. So here we had 3 sig figs. And so we're using 3 sig figs the whole way out. We have our square rooting, which has the same rules as multiplication and division. So our answer should go to 3 sig figs as well. So our change in time there is 2.02 seconds. So just remember your units follow the same as, say, your other units like your speed and your acceleration. Here we're working with the time as seconds and the time in our velocity there are seconds as well. So our answer in terms of time is going to be seconds as well. It is also not a vector quantity, so you do not have to write a direction for that. That would be a little bit silly. What we do need to do though is, because this is that continuation of that word problem, we do need to write a sentence. So we could say it takes the pebble 2.02 seconds to reach the ground. So one thing I do want to make sure that's really important is that for some of the other examples that we did in our lesson is that we can often use our A value, so that 9.81. This one here could be negative depending on what your motion is like. So if your speed is, maybe you're throwing an object up, then that gravity is pulling it down, so it's going in the opposite direction. So we actually need to make this acceleration negative. So be very careful that in your questions, in all the examples that we've been doing in these videos, your gravity and the acceleration has been in the same direction as your speed or velocity. So we don't have to worry about making any of those values positive or negatives. So we've just been leaving them as they are. But just watch out. So if one object is being thrown up, but gravity is bringing it down, then that gravity has to be negative to show that it's not pushing it up farther up into the air, but it's actually pulling it down and it's going to be slowing it down in that sort of sense. So that is everything here for this video. So if you guys have any questions, make sure to come see me in class, or you can text me on Remind 101. And thank you guys so much for watching.